Good day. This is meteorologist DT from Wxrisk.com doing our first look at winter 2018-19. I wanted this done about 3-4 weeks ago, but the broken foot and other problems here slowed me down a little bit. But finally got this done. So a lot to talk about here. And most of these winter speculation forecasts are usually fairly short at this point. But the way I do things here at Wxrisk is I like to teach and I like to show how the thought process, the scientific process is used in putting together seasonal forecasts, because it's not all witchcraft or guessing. So that's why I'm going to take the time out here to make this, go through the slide presentation. Hopefully you guys will enjoy it. All right, so here I'm going to start out by taking a look, and we have three different options. The snow dog, which everybody loves, yay for the snow doggy. The heat miser, which nobody loves, and of course just plain old rain. So here we go. I'll start out, let's go to slide 2 here. Generally, there are three types of winter seasons over the eastern U.S. This is severe or prolonged winter, which is, often referred to as a historically bad winter, like we had in 2012 and 13, or 1976, 77, or 77, 78, or what have you. 95, 96, which had a lot of snow. 2002, 2003. Then there's a normal or climate winter. Actually, last year was fairly close to normal or climate winter for much of the eastern U.S. And then there's also the mild or wet winter, which cursed be its name if you're a snow lover. So, or if you buy energy, or so what have you, trade energy. All right, the severe or prolonged winter will start out, early mid-November, last into March, even early April. Or it can even start in early mid-December, but it goes full blast into early March with few, if any, mild intervals. So either one of those two types are usually classic severe or prolonged winter. It can feature near normal temperatures for most of the winter, but can have numerous snow events as well. Or it can feature sustained below normal temperatures for much of the winter, but with near normal or below normal snowfall. So examples of this was the 76-77 winter, which was severely cold, as many of you recall, but it had no snow. 77-78 was cold and had a ton of snow. 95-96 featured seasonal cold with a lot of snow on the East Coast. The same thing in 2002, 2003. 2009, 2010, a big snowy winter, lots of cold there. And then the severe cold with moderate snowstorms, about 20 of them, on the 2013-14 winter, and also 12 and 13. Forgot to include that one. All right, the normal winter typically begins mid-December, but it may hold off until Xmas, Christmas Day, the Christmas week, that sort of thing. Often features cycles or intervals where the pattern will favor cold and mild, snowy patterns and rainy patterns, or active and then quiet. This kind of winter usually features the classic January thaw, and the winter will start in early to mid-December, will go full blast into early March. And again, we will have our intervals of in mild intervals there from time to time. Often there's an interval, again, which will feature to about 2 to 4 weeks, the coldest temperatures and the most snow. That'll be the heart of the winter. Like I said, it can be 2, 3, or 4 weeks long. Often there's an area or a subregion, let's say in the eastern half of the country or the Midwest, where you'll get significant snow. Let's say it'll be a Midwest pattern or a New England pattern, but the Mid-Atlantic will be constant missing. And the winter classic example of these types of winters: 2017-18, 2014-15, 2010-11, and 1986-87. All right, and then there's the mild winter. Most of the mild winters over the eastern U.S. usually start late, with no significant cold air outbreaks until the last week of December or the first week of January. Sometimes you'll also get it will start in December, then the pattern will break down in mid-January, and the second half of the winter is crap. Usually you'll have much below normal snowfall over most of the eastern U.S. in the mild winter. Most days you'll see normal temperatures or above normal temperatures. Often the mild winters will feature a week or two of above and much above normal temperatures over the eastern half of the country. And a mild winter will often have no significant widespread Arctic outbreaks. Sure, there'll be cold air outbreaks, but even those will have more Pacific air than Arctic air. And examples of this winter were 72-73, 2001, 2002, 15, 16, and 11 and 12. So there you go. Mild winters there. All right. So all seasonal forecasting, it's a third science, it's a third art or intuition, and the other part is a third guessing. Really, it's what it is. We're better than we used to be 20 years ago, but it's still a crapshoot to some degree. What we look at is a key set of atmospheric assumptions. We think this is going to happen and that's going to happen, which will produce that result. So large-scale hemispheric forces, which are called pattern drivers, like El Nino or La Nina, or the Pacific Decade Oscillation, the weak sun cycle, the autumn buildup of snow cover in Siberia, the QBO, quasi-biennial oscillation, sea surface temperature, soil moisture. These are all different types of pattern drivers which develop in the autumn, which help shape the winter pattern. And of course, these pattern drivers in turn set up the teleconnections, which drive the pattern, weekly or every 2 weeks, like the Arctic Oscillation being negative or positive, or the EPO being negative or positive, or the NAO being negative or positive, or the PNA or what have you. So the key teleconnections, which in turn they set up the weekly and daily weather maps, the low pressure, the cold fronts, the storm tracks, that sort of stuff. So we have pattern drivers, which affect the teleconnections, which affect the daily and weekly weather maps. Bada boom, bada bing, bada bang. There you go. Now, like I said, it's all based upon the key assumptions. A case in point is the consensus forecast for the summer of last year. Now, if you recall, it looked like we were going to get a moderate El Nino coming with below normal temperatures over the plains of the Midwest and above normal rainfall, and much below normal hurricane season. Almost everyone had this in their forecast in April and May of 2017. Classic example of groupthink. And what actually happened? Well, here we go. These are the news stories. Now take a look at the date on the news stories here. This is May 2017. Full-fledged El Nino likely second half of 2017. Well, that didn't happen. That wasn't even close to happening. All right. So there you go. And then here's the next slide. Yeah, this is, again, you can see 2017 hurricane season forecast, possible El Nino to limit the storms. This is from AccuWeather. I'm not bashing AccuWeather, I'm just pointing out they carried this story as well. This is from May, and you can see that Hurricane News Weather Channel, same sort of thing. April 26th, there you go. Well below her, constant reference to that, and that's fine. They all have these key set of assumptions. That's my point. And what actually happened? There was no El Nino last summer. And you can see these on the satellite pictures. It didn't happen. June, July, and August. There you go. And what happened? Extremely active 2000 Atlantic hurricane season finally ends. We all know what happened. It was a catastrophe. So remember, assumptions. That's what we're dealing with here. Okay. So the information I'm going to present here for Wxrisk is this is not a forecast. This is what I call winter informed speculation. The assumptions and educated guesses made here in late August and early September are just that, assumptions and educated guesses. Between now and say November 15th, the data will change, the models will change, the information will change, the trends will change. Okay, now we got that down. Let's get into this. All right, the key assumptions, the pattern drivers are a weak to moderate El Nino develops this autumn, likely lasts the winter months. A possible special type of El Nino called a Mordecai El Nino is going to develop, maybe. The current long-term soil trends seem to favor the mean trough staying over the eastern U.S. through the autumn into the winter. We have a weakening negative QPO. That is to say, right now it's around minus 25 or 26. It's going to rise towards zero as we go into the winter months. And an early look at the climate models. All right, the El Nino. This diagram, you may have seen it before, shows you what the El Nino is. It is a region along the equatorial Pacific. And you can see it runs from South America, Peru, out towards in New Guinea, Indonesia, the Philippines. Now, the red area is El Nino region 3.4. That's the one that we look at to determine whether we are in El Nino or neutral or La Nina. So this. I just want to give you this diagram, and you can see. Now, to the north, if you notice on the diagram, there's something there called the PDO, which you can see here. And that, of course, involves the water temperatures in this portion of the Pacific, which affects the flow of the northern jet stream. But that's different. Right now, we're just going to talk about the El Nino. Now, this is a nice chart here because it shows you the El Nino all the way back to 1950. And, of course, the peaks, this is El Nino up in here, right? So this is your El Nino, and this is La Nina down in here, right? So this is your zero line right through here, as you can see it. So, and again, like 2011, 12 was a La Nina, 2010, 11, 1980, 89, so on and so forth. This was the big one we had a couple winters ago. This is 97, 98. This is 82, 83, and so on and so forth. So this is strong, and this is the moderate level in here, and this is the weak level in here. So this gives us an idea, and we can use this as a reference point. Another way of looking at this is taking a look at this chart here. And again, you can go back to the video and look at this chart. This is on the internet, and I've added 2015-16. So there you go. Now currently, let's talk about the El Nino. This is August 8th, and you can see that there's a new pool of warm water which is developing at the subsurface level and pushing up towards the surface. And when it does that, we'll see a rise in the El Nino and more intensification of it. Right now, it's very marginal. And the climate models, this is from August 9th, and you can see the trend. Now, I could post the latest ones here from August 25th, 26th, but the trend is not really different. We can see the clear trend is going up. The black dashed line here, this is the mean. So it goes up, reaches a peak in October, no, actually November, and then look, it kind of weakens slowly as we go into January and February. So that's an interesting trend. Definitely not a strong El Nino, no doubt about that. Definitely not one of those. Now, why is this important? Well, there are different types of El Ninos. So this map will show us 4 different types of things. Excuse me. On the left, the upper left corner, map A, temperature anomalies for all El Nino events. In the old days, before we knew much about El Ninos, we used to think, okay, El Nino, warm winter, boom, that's it, over and done. And we know that's not true anymore. So that's what A looks like. B is the temperature anomalies of weak El Nino events. And you can see this is biased for it's colder than normal temperatures in the Midwest, in the Northeast, Mid-Atlantic, that sort of thing. C are temperature anomalies for moderate El Nino events. And here you have the central and southern portion of the country colder than normal, milder over Canada. And then near normal, the upper plains, upper Midwest. And then finally, area D, which is when you have a strong El Nino. Everybody torches. Okay, so that just gives you an idea of what the different types of El Nino events we can expect. Or that are possible, the different type of conditions. All right, so another way of looking at it is this slide here. Now this gives you warm, neutral, weak, moderate, or strong. And what we're looking at here, again, if we assume a weak El Nino, which is an assumption, we're looking at this. Now you see there's a bias for colder than normal temperatures December, January, and February. Now if we get to moderate, it changes a little bit. But again, notice February is colder, and so on and so forth. Generally, January and February are colder than December in all the El Nino conditions. So just keep that in mind as well. Okay. Let's take a look at some of these models. This here is the British model in the upper left. You can see that. It shows, again, notice it has a peak. It gets to moderate in November. Here's November, right up in here. And then look at the drop-off. The French model, okay, right here, gets to 1, which is a weak moderate, and then drops off. So that is a trend which matches the CFS very nicely. Now this here is a Japanese model. Same sort of thing. Notice it reaches a peak around November, December, towards January. Then it drops off through the second half of the winter into the spring months. And of course, this is the European model from August 1st. The European model did a spectacular job with the strong El Nino in 2015 and 16. So, again, you can see weak to moderate, and then look at the drop-off in January and February. There's a trend. We'll see. This is more of the climate models here. This is from the NME, different climate models, all showed together. And of course, the strongest of all the models, not surprisingly, is the American CFS model. Notice it's completely alone up in here. I mean, it's ridiculous. All the other models have a weak El Nino, but it gets moderate, and then so that's just the CFS for it. It's just, what are you going to do? American model junk. Okay. So then this is the Australians. Now, this is a significant change. This was the old one down in here. Okay. This was July. This is August, the new one. Look at the difference. Here is completely flat. Now it gets up to weak to moderate. Right there by December, January. So that's, again, supports the same trend. And of course, if we look at the different climate models from the Australians, they have a nice way of showing the climate models, 8 of them. You can, November, the dashed line here, that's the beginning of El Nino. And you can see that, and then November and January. Okay. Slide 27 here, we'll take a look at the CPC IRR site projections. They think the probability of getting El Nino during the winter months is about 70%. Now, we can take a look at some different stuff. This is from Josh Timberland, and you can see Central Park. We have here the upper left maps are snowfall for all the events, and then temperatures. And again, this is New York City. So we can see weak conditions here. That's what we're focused on, the weak conditions. Temperatures, generally, they run below normal for weak El Ninos, and then snowfall is a little on the high side, generally higher than normal snowfall in a weak event here. Now we're going to go through the other slides here. This one here is Richmond, Virginia. Notice we have a big display. When you look at neutral, everything, all different types of snow years. Weak, not showing, the weak El Nino is not showing much of a bias one way or the other. Generally, it seems to be above normal snowfall for Richmond. Excuse me. In the during the weak El Nino, and temperatures also generally below normal. All right, this is Washington D.C. Same sort of thing. And you can see the snowfall and the temperatures are generally below normal temperatures in El Nino years. All right, this is Pittsburgh out in the Appalachians, the Ohio Valley. You can clearly see weak El Nino showing a bias above normal snowfall, and then temperatures generally below normal in the bottom right. All right, this is Indianapolis here in the Ohio Valley again, and temperatures definitely below normal. And then finally, this here is Chicago, which is, again, almost an equal split with snowfall, but definitely below normal temperatures. All right, now let's take a look at the different types of El Ninos. Now, this is the classic El Nino here from November 15th on the upper left map. And you can see how the warm waters there spread from Peru out to the Central Pacific, south of Hawaii. Then the bottom right image shows a different development. The bottom right image shows the core of the warm water is in the central equatorial Pacific, and it's actually colder than normal off the coast of Peru. That bottom image is called the Molokai El Nino. You can see what it looks like here. So you can see how the warm waters in the central Pacific, and the classic El Nino is the image on the bottom off the coast of Peru, where it spreads out on the equatorial Pacific towards the Philippines. So that's the issue. Which type are we looking at here? And again, this is two classic examples. The December 82-83, very, very strong El Nino, and the one in 1997-1998. Look at both these examples. Core of the warm water, Peru, spreads out on the equatorial regions from east to west. Now, this gives us a table here of where we have an eastern Pacific, a regular El Nino, or the central Pacific, the Molokai El Nino. And you can see the stars in red are the ones which were particularly bad winters in the eastern United States. Now, there's a tendency, but not certainty, of having pretty good winters when you have the central Pacific. Now, there have been some good winters like 76, 77, which was really cold, but not a lot of snow, where you had a classic weak El Nino off the coast of Peru, eastern Pacific El Nino. So it's not a guarantee by any stretch of the imagination, but there's a tendency for that to be the case. And how does this work out? Well, this is the regular weather pattern when you have an El Nino. Now, the image on the left is what the pattern typically looks like. The trough is on the west coast. You have a ridge of high pressure over central Canada, eastern Canada. So as a result, all the energy is shoved to the south. There's no way to get the cold air into the U.S., and you have a mild winter. And this is what the models look like when you run the climate models, where you have a regular, moderate, or strong El Nino, you get this sort of weather pattern. So this shows us very nicely why when you have a moderate or strong El Nino, you end up getting often a mild or normal winter, and what it does to the overall pattern specifically. But when you have a Molokai El Nino, this is what happens instead. Vastly different weather pattern. You end up getting a huge ridge of high pressure over western Canada, which allows the cold air to flow southward. The storm track is shifted south, so you get a lot of coastal storms, and you end up getting a much stormier winter. And we can see how that takes place here. This is another diagram, and again, El Nino on the left with the off the coast of Peru, the regular El Nino versus the Molokai El Nino on the right-hand side. And you can clearly see how the pattern is shaped differently. So, in the southwest here, this refers to the track of the low pressure. So the lows go like this. Okay, and this is warm for the eastern United States. Here, you get this sort of track, and you get a lot colder and a lot stormier pattern. So, again, for winter weather lovers, if we get a Molokai El Nino, that would be really great. All right, slide 41 here. Climate models are clearly showing the UCMET, a Molokai El Nino out there, and again, this is from August, and the bottom is the European model. Again, November, December, January, clearly showing Molokai El Nino. This is the climate model from August 12th at CFS for November, December. Very clear Molokai El Nino. You can see it right here. Okay, and that continues beyond that. And again, you can clearly see it in January and February. So these are all great signs. Okay, now so that's one area. Let's go on to the next pattern driver: soil moisture trends. Just like in the Atlantic and the Pacific Oceans, where large, long-lasting pools of warmer or colder than normal anomalies can and do affect the long-term climate patterns, large sustained areas of saturated or drought conditions on land can and do affect the weather patterns. Well, this is the long-term trend as of August 18th, and you can see generally that this area is wetter than normal. And that would imply the trough staying in this sort of position. Indeed, we've seen that all of August. That's why it's been so darn rainy on the East Coast. So that's an interesting trend. And of course, it's drier than normal in the southwestern states, and that would support some sort of ridge. So this is what the trend is looking like. And the short-term trends here, again, we can see much of the eastern U.S. remains wetter than normal. Over the autumn, it'll be important to see if the eastern U.S. stays wet and saturated, and if the Midwest continues to turn wetter than normal. If that happens, it would favor the sustained mean trough staying in the eastern United States, which would mean more cold and no snow, and more snow. If that holds, we don't know if it's going to yet. We have to watch that during the winter. All right, let's talk about the weakening negative QBO. Well, what is the QBO? The QBO is the quasi-biennial oscillation. It's a level of high wind. You know, they discovered this back in World War II. We used to fly the big plane bombing flights over to Japan from the equatorial regions. So it's at the top of the atmosphere, 30 millibars, almost at the edge of outer space. Now it exists right along the equator. And what it does is it goes from east to west, and then it becomes neutral, then it goes from west to east. So these oscillations, this cycle can take anywhere from 18 to 30 months. Now the strongest positive values are usually around plus 15, and the strongest negative values are minus 25 to minus 30. So the QBO winds, the phase, the direction of the QBO, they work their way down to the low levels of the atmosphere and the jet stream, which ends up affecting the weather patterns. So I got you some links if you want to read more about it, and also the actual QBO data. All right, so what? Why is the QBO important? Well, strongly positive QBO values correlate to non-blocking weather patterns in the jet stream. And strongly negative QBO values in the cold months can also mean positive Arctic oscillation and positive NAO patterns, which means no blocking. But when the QBO values are moderately negative, not extremely so, but moderately so, it favors blocking patterns in the northern hemisphere. Last winter, the majority consensus for the forecast for 2017-18 called for mild winter, with below normal temperature over the eastern U.S. Now, Wxrisk correctly forecasted a much colder than normal winter, well, much colder winter than the consensus, and near normal snowfall for many. So what we saw was that the moderately QBO values would stay the same intensity throughout the winter, and that favors, not guarantees, favors a cold winter, all other things being equal. So Wxrisk 2017-18 assumed the negative QBO would last through the winter, and that's pretty much what happened. Now, in mid to late February, the pattern did turn warm, and it stayed, and that ended the winter a little early. But for the most part, the winter last year was a colder than consensus forecast, and we saw that's one of the reasons why we latched onto this idea. It was because of the QBO. All right, this is the QBO data. I just want to show you what it looks like. It goes back to 1948. So last winter, you can see we were consistently strong, moderately strongly negative, as you can see right in here. Okay. Now, if we go back and take a look at all the autumns and the winters where the QBOs were moderately negative, let's say from -5 to -20, we get this kind of pattern. Okay. So this is the overall 500 millibar pattern of the anomalies if the QBO stays negative all winter long, between -5 and -20. The Arctic oscillation is neutral. You can see there's a trough here over west coast of North America. There's also one off the southeast coast. We have pretty strong blocking over Greenland and eastern Canada. So overall, this is a pretty good looking map for in regards of a winter pattern. And if we take a look at this, break it down by December, the December pattern, when you have a sustained negative, moderately negative QBOs, are always very cold. And this is a classic winter cold snowstorm pattern here. This one right here. This is just ideal, this pattern here. You know, if this whole thing is just ideal if you love snowstorms on the East Coast. You just love that. There's a deep trough blocking over Canada, big west coast ridge, and you can see it's pretty cold. That's December. where again, moderately negative QBOs. This is January. Pattern's still pretty strong and pretty favorable. Okay, there you go. Cold pattern. You see the temperatures, good blocking, still snowstorm favored pattern for much of the eastern U.S. Cold winter for in New England as well. And then this is February. Breaks down. That's what happened last year. You remember how February turned really warm? The ski resorts had to shut down in February. Bada boom, bada bing. The pattern shifts in February when you have moderately strong negative QBOs. Now, what's going on right now? Okay, here's the latest. Now we can see we reached a peak here in July of minus 29.10. Now we're rising, minus 26.3. So the July value is tied for the most negative QBO value of any month since 1948. However, it now appears the QBO is weakening. That is to say, it's going up. Okay, it's rising here a little bit, and you can see it right in this area here. Now, so it's possible that come the winter, we're going to be somewhere around minus 10, minus 15, minus 8, something like that in December and January. Now, this is the new update. This is as of August 15th, August 10th, I should say. And you can see the light green down here? This is, let me get my marker out. You can see it right in here. You can see that, light green. And you can see that is around minus 24. So it is still slowly coming up to the zero line. Here's the zero line. It's still coming up towards that way. So the trend is there. Definitely the trend is there. All right, so what does that mean? Our analog years on the QBO are these years. 56, 57, 58, 59, 62, 63. All those were pretty good winters. 76, 77 was a severe winter. This was a big snowy winter here. This was very good for the lower mid-Atlantic, Virginia, North Carolina. This was pretty good for the East Coast. This was So we have some good winters in here. Not all spectacular, but decent ones. And of course, 2009, 2010 was a fabulous winter. Again, take a look at this. Here, we're going to look at all the negative QBO winters with a weak El Nino or no El Nino. Okay? This is what the pattern looks like. If you take those two factors and you put them together, this is what the pattern looks like. Okay. There you go. You have a block over Alaska, which is not ideal for U.S. winters. The trough over Western North America, again, which is not ideal for great winters in the Eastern U.S. Pretty good for the Midwest. And then strong, you can see that here, a negative QBO block, critical for the Eastern U.S. So that we have. So it's not a great looking pattern overall. If we break it down month by month, this is December. Okay, the analogs in December for negative QBO and a weak or non-El Nino, awesome. This is a great pattern for snowstorms over the East Coast, Eastern U.S. Negative NAO, negative Arctic oscillation, big ridge on the West Coast, deep trough, boom. And of course, it's nice and cold. If we go to January, same sort of pattern. Looks great. Broad trough over the entire Eastern U.S. You can see this here. Okay, and very strong blocking up in here. Also more cold and snow for New England, for Europe, I should say. And again, really cold temperatures over all the central and eastern U.S. relative to normal. But when we get to February, boom, it breaks down. Only on the East Coast you get normal temperatures, and that's where your storm track is. February might still be decent on the East Coast. The lows go up in that direction because of the blocking here. But everybody else, not a good pattern. So it ends in early February. All right, and so in summary, the QBO is tricky. It's not linear, and it can proceed at a steady pace for a few months and then suddenly make a big leap back and forth. It can even reverse course like it did in the summer and autumn of 2016. So yes, the QBO appears to be favorable for colder than normal and snowier than normal winter over the eastern U.S., but it's still a long way to go, and you have to follow with this winter. All right, let's talk about the sea surface temperatures in the Atlantic and the blocking patterns. Okay, so again, we have to worry about these ocean water temperatures, just like on the land, just like in the Pacific, same sort of thing. Now, this here is the current sea surface temperature map, August 21st, and you can see, again, here's the cold Atlantic in here. This is the warm water here. This is the cold water here. Now, that appears to be favorable for the NAO during the winter months if we can hold that. This is the classic setup. We have the cold Atlantic here, the warm water off the East Coast, and the cold here. That appears to be very similar to this. We'll see. Again, we have to watch it. This could change. This is August, folks. It could change in September. It could change in October, November. We'll have to watch it. All right, let's talk about the early climate models. Now this here's the European climate model from August 1st. We have here for the one on the left is November, and it looks kind of favorable, not that great, but December is just awesome. Look at this December map. Holy crap. Nice deep trough, big ridge. Out of Canada, this is a very, very, very nice looking winter map, and that continues here for January and February. I mean, this is ideal. I'm sure this is not going to last, but these are really good looking jet stream maps for the winter if you're a winter snow lover. And again, this is from Ben Knoll, guy from Australia, but he's actually from New York, but he's in New Zealand, I should say. And he posted these on his Twitter page, the snowfall maps from the European for December, January, February. And you can see there's the blue shows above normal snowfall, and it's pretty good in a lot of other countries, especially over the northeast U.S. Finally, I guess, well, not finally, but close to the end here, the solar cycle looks very weak. The sun is weakening, and this is a lot of controversy. Some people think this is BS, some people don't. I think there's something to it. The sun is in a very weak cycle. It continues to be quite weak, and we can see the impact of it here. One thing that's interesting, it may just be coincidence, but it might not be. When we reach the last minimum, this is when we had the big winter 2009, 2010. And then back here, the big winter of 95, 96. Look where we're headed to now. Again, doesn't necessarily mean anything, but it's one of these things where we're beginning to explore, which seems to have some sort of connection to the overall pattern. Indeed, if we take a look at this with the how it affects the overall pattern, again, if we're at low sun intensity with very few sunspots, we get, look, in February, we get more of this blocking stuff. See this above normal heights in Canada and Greenland and the Arctic regions? Also in January, see that? To some degree, December, and also for the whole winter. So when the sun is very weak, which is what we have now, again, maybe something to look forward to. All right, so in summary, again, this is not a forecast, this is form speculation. This autumn, we still have to watch the El Nino development, whether we have a Mordecai, the QBO trends, the sea surface temperatures in the Atlantic, the sea surface temperature anomalies in the Pacific, especially things like the PDO, and whether or not that's going to cause a ridge to form in the west coast of North America. The climate models, which get better in October, November. The soil moisture trends in September, October, November. Of course, the Siberian snow cover in October, and whether or not, again, the autumn PDO, the warm waters, cold waters in the North Pacific, and the Arctic Oscillation development. So this has been a long video, a lot of information here. I'm favorable for the winter. I think it's going to be a pretty good winter, but it's really early and really speculative. Hopefully this video has showed you how a forecaster goes about making a early season forecast, for the next season. Remember, winter is still the next season after autumn. So this is meteorologist DT from Wxrisk. I'll talk to you soon.